Okay, YouTube. Here we are back again looking at writing an interpreter in Rust. And I think the last time we stopped here at the operators. So let's try to do that. Last time we had this basic implementation of the scanner, which looks through all the tokens that it gets when it's initialized, or it looks through the string that it gets when it's initialized, tries to tokenize it. And we had implemented this thing where we support single character tokens, but now there's, for example, operators. So let's try to see what to do here. So what we want to support now is multi-character operators. For example, the bang or the not operator is a single character, but if it's followed by an equal sign, it becomes a multi-character operator. So what we want to do is to see that if we get a bang, then we want to, as it says here, add a token, but depending on whether the next character is an equal sign or not, we want to add different things. So we can do that like he says. I want to write it a little bit differently actually. So let's say let token equal if self.match. So this match function is supposed to look at the next character and check what it is. And if it's an equal sign, then we have this string of characters, and then we want to get a bang equal. Otherwise, it's just an equal. And then we want to add that token. And that's it. Token added. And we should be done. Okay, it doesn't like that we use match, so let's write something like char match. Now we need to write that function. Let's implement it. Let's make a stop. It should also increment the pointer, so we need a mutable reference. Okay, if it's an equal sign, then we also want to do something. And I just took the liberty to add the remaining functions, or the remaining cases rather. Let's check that it is okay. It's not okay because I wrote self here with small s. And we forgot here that this one needs an input argument. So let's check it again. Because it's not used right now, it gives a warning, so let's allow that. Okay, and now it's just user warning. So then let's implement this match method. And we should have this is@end function. And we don't need this. But otherwise, we want to do this. probably we have to cast it. If that is not equal to the supplied character, then we can also return false. But if it is, then we want to increment the pointer and return true. True. Let's try to compile that. Again, it seems to work. Okay. Yes, so like he writes here, it's like a conditional advance. We only consume the current character if it's what we're looking for. Using match, we recognize these lexemes in 2 stages. If we reach like a bang, then we have to check whether it's bang equal or equal. Makes sense. Now longer lexemes. We're still missing one operator, / for division. The character needs a little special handling because the comments begin with a /2. Yeah. So probably we are going to write something like advance to end of line. Yeah, so we want to loop and if self.peak is equal to a new line, or we are at the end, then we want to break. Otherwise we do advance to skip the comments. Not debug. Missing something. I think we need this. We're missing some kind of brace. Do we need just a comma here? It's because I accidentally put a brace there. Okay. So we have that. Now we need the peak. And peak is not changing anything. So it doesn't need a mutable reference. We just want to do this. Okay, if self is at end, then we want return a null character. Otherwise we return self.source as bytes. Okay, that works. Yeah, so what we did here is it tries to look at the next character, which is what this line does, and return it as a character. But then we have some error handling. If we're already at the end, then it will return this like zero character. Yeah, so peak is advance kind of, but it doesn't consume the character. And let me see. Else add token /. So that's what we need. So if that, else we should add a /. Okay. Great. So he writes kind of an interesting thing here that Comments are lexemes, but they aren't meaningful. When we reach the end of the comment, we don't call add token, and therefore the lexeme disappears in a puff of smoke. But you could add some built-in compiler support, like you could support triple slash or something like this, or I don't know, something you can think of it, where it's a comment, but it gets, the compiler does something with it, maybe produces some output file, like some automatic documentation that's not a tool that you use from the outside, but it's built into the compiler. But let's try to continue with this. So while we're at it now, it's a good time to skip over those other meaningless characters, new lines and white space. So, is there a way to match multiple things in Rust? And the answer is yes. You can do something like this, which is exactly what I want. So we can say, okay, we ignore, just basically do nothing for that. And if it is a new line, we just want to say line plus equals 1, or rather self.line. And there we go. When encountering white space, we simply go back to the beginning of the scan loop. Yes, this starts a new lexeme after the white space character. For new lines, we do the same thing, but increment the new line counter. So all right, scanline is getting smarter. It can handle fairly free from code like this. Okay, let's write a quick test. Okay, just a small bug. This should be slash like that, and here there was a semicolon. But back to testing now. So I wrote this quick test. I'm not sure if it works because of all these errors. So here's another error. It's because I should call new on that. Now there is another warning. Let's just heat that so we don't need this. And let's see if the test worked. So we can go down here and say scanner.scan tokens. And then we should be able to say something like scanner.tokens, the tokens field. So we should say the length of that. There should be 4 tokens here. And we should be able to do this. So we want a left paren. Let's just run that. Binary operation cannot because it doesn't have an implementation of partial eq. So let's just add that. And it is actually down here. I want to not assert on the token, just on the token type, at least for now. Right, so we need to make this mutable. And test failed because we have this not yet implemented thing inside scan token. Let's remove that for now, because otherwise we'll never get this working. Okay, so go up here. It's supposed to return a result, and here we fail, but otherwise we just should return okay. Good. Let's run the test. And again it failed. Okay, that's interesting. So it has 5 tokens inside. And why should that be? Let's see what the tokens are. Debug scanner the tokens. Then we need to run this, the no captcha. Value is moved. That cannot be right. And here we have the tokens. So there's a left paren. There's a left paren. There's a right paren. There's an end of file token. Okay, I had forgotten about that thing. So, seems to be correct. Now the test is okay. Now we can kind of repeat this a couple of times. This should be right paren. The same here, right. It should be end of file. End of file, T. And that also failed because I forgot to increment this thing. Okay, now the test is okay. So let's add another test with some with these types of things. And okay, now we have that test, and it's the same same structure as before, but here now the source is bang operator space bang equals space equal space greater equal. And then we assert on it here again, and let's see if it works. It did not work. So for some reason here in this guy it thinks it's an equal operator. So let's go up to the line where we pass that. I don't know why my search doesn't work for that. Whatever. It's because for some reason I wrote equal here, so good that we had that test. It should be bang. And now it works. So we should probably add just a couple of more tests. Let's do this. And then it should be right brace, left brace, the length should be now 7, and I think at this point I'm happy. So next time we will try to deal with string literals. All right, see you then.